Hi, my name is Nikhil Savarjala and I'm from Dublin High School in California.
My name is Janya Gupta and I'm from Dublin High School in California.
My name is Arnav Saini and I am from Amador Valley High School in California.
We are the co-founders of Dravix. Dravix is an early-stage fire risk screening system that helps engineers avoid costly material testing failures before they ever reach a lab. Dravix uses computational prioritization before physical fire testing, which helps engineers allocate their materials towards the most viable candidates.
Dravix comes from Dravya, the Sanskrit word for substance or materials. This inspired Dravix's goal to help engineers build safer materials.
In current engineering workflows, fire resistance evaluation occurs late in development, forcing teams to commit significant time and resources to physical testing before knowing which materials are viable due to the absence of reliable early-stage screening to guide better decisions sooner.
Each physical fire test can cost thousands to tens of thousands per iteration. This means that teams lose time and resources. Even one avoidable failed test can erase significant R&D investment.
Dravix is upstream compared to sim tools and certification standards like ASTM or UL. Dravix doesn't replace fire testing, but instead helps engineers decide which materials are worth testing by generating a relative fire risk screening score for prioritization. Traditionally, we see that materials move right into lab testing where failures are discovered late. Dravix does computational screening first, which narrows candidate sets before commitment. Dravix reduces wasted iteration while keeping the authority of formal certification processes. Existing solutions optimize downstream validation accuracy. Dravix introduces a new architectural layer, early-stage predictive narrowing. Rather than competing within the testing landscape, we redefine when fire risk intelligence enters the engineering pipeline. We're not building a better fire test, we're creating a new layer of engineering decision intelligence.
Our initial focus is materials manufacturers and product developers already operating the testing ecosystem. From there, Tier 1 includes startups that lack resources for extensive testing. Tier 2 includes research institutions developing novel materials, and Tier 3 expands into industries where fire testing isn't the standard but would still provide value, like wearable technology. This phase expansion allows Dravix to scale from regulated environments into broader innovation-driven industries.
Dravix's Blue Ocean strategy focuses on redefining value in the workflow. We eliminate blind material selection and dependence on physical testing. We reduce development costs, testing cycles, and innovation risks. We increase confidence, validation speed, and experimentation. We create predictive fire intelligence that supports data-driven material engineering. Instead of reacting to failures, we can now proactively manage fire risk earlier.
Dravix shifts value from late-stage correction to early-stage prioritization, lowering evaluation costs and enabling faster, more informed materials decisions. Now we'll show how Dravix performs in practice and how its screening signal aligns with established fire science indicators. Dravix is a Stage 2 engineering prototype with a deployed website, live dashboard, and operational API. Validated inputs pass through a deterministic inference pipeline to produce interpretable screening outputs, ensuring identical inputs generate identical results for reliable engineering comparison. Uncertainty is explicitly surfaced through stability and material class variance checks. Outputs are flagged when confidence is lower, and framing adjusts without modifying predictions, preserving transparency in safety-relevant contexts.
The system produces continuous screening score, relative ranking within candidate sets, and feature-level explanations. It does not certify materials or determine compliance. Physical testing remains mandatory. Dravix supports earlier prioritization, not regulatory replacement. The screening proxy shows strong positive correlation of approximately 0.86 with external heat flux and moderate negative correlation with time to ignition. These relationships align with known ignition dynamics, confirming that the model preserves meaningful physical trends for ranking and down selection.
The model is trained on over 700 materials across polymers, composites, and broader classes. It operates in a fixed evaluation state, producing deterministic, reproducible screening results under identical inputs.
Over the next 6 months, we will expand datasets, initiate controlled pilot use, and refine the system based on real workflow feedback. Our focus is disciplined integration into engineering environments before scaling further. Physical testing costs tens of thousands to hundreds of thousands of dollars per iteration. With Dravix as an internal engineering tool, even a single avoided failed test can offset the entire subscription cost. The value of Dravix is that it reduces iteration volumes and improves resource allocations. Reducing unnecessary test cycles by even 30 to 60% provides immediate economic justification. Over the summer, our team will file a non-provisional patent to protect Dravix's core architecture and system design.
Dravix is a constrained, interpretable, deterministic screening system.
It reduces uncertainty before physical testing begins.
Materials engineering is a safety-critical field. Improving early-stage decision-making is imperative. Dravix shifts fire risk evaluation from late-stage reaction to early-stage proactivity. That is Dravix.